Hello everyone. Today we will talk about scientific and engineering notation. So first we're going to review a little bit about scientific notation. Now I know that you did scientific notation in your chemistry class, and those of you who had physics, you had it in your physics class. So it should look familiar to you. So any number can be written in scientific notation, and scientific notation generally means you have one digit in front of your decimal point, and then you have 10 to some kind of power. So for example, I have 1.234 times 10 to the, let's see, 5, right? Now that number, if we turn this into a big lot number, it's going to be 1, 2, 3, 4, 0, 0, right? So what I'm doing in my scientific notation, I grab my decimal point and I move it until I have only one non-zero digit in front of my decimal point. Then I count the spaces I went and I'm done. So very, very straightforward. The key fact that we need to remember about scientific notation, you can have only one digit before the decimal point. You cannot have two. So for example, a number like this is not in engineering, in scientific notation. This is not a scientific notation. You have to have just one. Okay. So what if I have a small number? How do I put that into scientific notation? Well, let's have an example. Here's a nice number, and I want to put this in scientific notation. So I'm going to grab my decimal point, and I'm going to move it until I have one digit before decimal point. 1, 2, 3, 4, 5. Now I finally have 3 in front of my decimal point. I can stop. So now I'm going to write down the resulting number. So I have 3 in front of the decimal point. Then I have the rest of my number. And now I'm going to count how many times I went. So let's see, I went 1, 2, 3, 4, 5. So it's times 10 to the negative 5. So how do you know which one it is, positive 5 or negative 5? Well, if you have a very large number, it's gonna be positive. If you have a very small number, it's gonna be negative. Another way to tell is take a look which way you go. If you are moving your decimal point to the left, so let me get an arrow to the left, then you are going to have a positive exponent. Now, if you're going to move to the right, you're going to have a negative exponent. All right. So that is really all there is to know about scientific notation. Here's the thing with scientific notation. We actually are not going to use it in class. The only reason I reviewed it right now is because we're going to use something called engineering notation, which is extremely similar but have some very important differences. So what's the difference between engineering notation and scientific notation? Remember, in scientific notation, you could have only one digit in front of the decimal point. In engineering notation, you can have one digit, 2-digit, or 3-digit number as long as it is a non-zero number in front of the decimal point. So 1 digit, All right, so how would that work? Well, let me get a number. I'm gonna use a big number. So here's my rather large number, and I'm gonna put it in engineering notation. So the first thing I'm gonna do is I'm gonna move my decimal point, just like I did in scientific notation. But instead of moving by each decimal space, I'm gonna go in sets of 3. So I'm gonna go 1, 2, 3. And as soon as I went 3, I'm gonna check. Is the number in front of my decimal point 1, 2, or 3 digit 1, 2, or 3, let's see, 3 digit number, non-zero number? So the answer in my case right now is absolutely not. This is still have lots and lots of digits, so I'm going to go 3 more. Is the number in front of my decimal point a 1, 2, or 3 digit number that is non-zero? The answer is no. So I'm going to move 1 more. And now I have a 1 digit number in front of my decimal point. I can stop. So the next thing I'm going to do is I'm going to write down that number. So I'm going to have 4.3567, and then I'm going to figure out my power. So I went in sets of 3, and I went 3 times, so that makes it a 9. So this is 10 to the 9th. There we go. All right. So this is very straightforward. What you will also notice that in engineering notation, you will always end up having your exponent as some kind of multiple of 3. So it could be 3, it could be 1, obviously, right? It could be, well, it could be 0, not 1, right? It could be 6, it could be 9, it could be 12, 15, all of those. So how do I know is my exponent positive or negative? The same way I did in scientific notation. All I have to do is look which way I went. This time I was moving my decimal point to the left, therefore it's positive. So let's do another number. 0.000034. All right. So I'm going to go and start by moving by 3. So I move my decimal point by 3. And then look, is the number in front of my decimal point a non-zero 1, 2, or 3 digit number? The answer is absolutely not. So I have to keep moving. And now I have a number 34 in front of my decimal point. That's great. That means I can use that because it's a 2-digit number. So I'm going to go ahead and write that out. (34 times 10). And I went twice. So 2 times 3 is 6. But I also went to the right. Therefore, it's -6. So 34 times 10 to the -6. So what are my steps in putting numbers in engineering notation? So first, move. So let me, okay. So my step 1 is going to be move your decimal point in sets of 3 until you reach a point where you have a 1-digit, 2-digit, or 3-digit number in front of your decimal point. Okay, so this is step number 1. And step number 2 is figure out what is your exponent, right? So figure out how many decimal spaces you moved and in which direction. And honestly, that's it. It's very straightforward. So let me do some examples. Here's one. 0.0004. All right, so let's do this. So I'm going to grab my pen and I'm going to go in sets of 3. So I went 1, 2, 3. I don't have a 1, 2, or 3-digit number in front of my decimal point. I need to move some more, but I have a problem. I have only 1 digit. That's perfectly okay. If I were to rewrite this number as 0.000400, I would change nothing. All I'm doing is adding precision. So now I can easily move into another set of 3. So my final answer is going to be 400 times 10 to the 6, because I went 10 to the negative 6, because I went twice and I went to the right. All right, let's do another example. Here's another one. Okay, that's a lot of zeros. I don't even want to read that number. But I'm sure we can do this. So I go in sets of 3. 1, 2, 3. Do I have a 1, 2, or 3-digit number in front of me? In front of my decimal point? Of course not. So I have to keep moving. And then I have to keep moving. And now I still have a 5-digit number in front of me, so I still have to keep moving. Now I have only 2-digit number in front of me, which is great because I can use that. So my answer is going to be 14.5 times, and I went 4 times. So 3 times 4 is 12. And I went to the left, so it's a positive 12. So here's my answer. Very, very, very straightforward. So let me do one more example. So here's one. 0.000067. Okay. So let's do this. So I go 1, 2, 3. I still don't have a non-zero number. I go 1, 2, 3 more, and now I have a 1-digit number in front of me, in front of my decimal point, so I can do this. So I'm gonna say 6.7 times 10, and since I went twice, it's a 6, and I went to the left, so it's gonna be a negative 6. So times 10 to the negative 6. And there we go. They're all done.